Hey guys, did you ever try to process your geospatial data without using the GIS softwares like ArcGIS or QGIS? If not, this is the completely beginner level video for you. In this video, I'm going to show you the process of reading, writing and visualization of geospatial data using Python. In this video, I am going to use the GeoPandas library, which is the Python library for geospatial analysis. So let's get started. So here is the table of content for this section. So first thing, we are going to install it and import it, and then I'll show you the process of reading the vector data set like GeoJSON or shapefile, and then I'm going to show you the visualization of vector data, so how we can visualize it. And after that, I'll show you the process of writing data. That means we do some analysis and then we save it as a in the file. Like we can even save the shape file into GeoJSON or GeoJSON into shape files. So yeah, we can easily convert the format of our file. And after that, I'll show you the working with attribute tables, things like we can filter the data based on any attribute table, or we can even generate the area or length of the your data set by simply using the GeoPandas feature. So after that, I'll show you the working with geometries. That means the vector operations, like we can create the buffer zone, or we can even I'll show you the how to create point, line and polygon shape files. And then after that, I'll also show you the how to like merge the attribute table with your geometry, something like this. So as I already said, GeoPandas is the open source Python package for reading, writing and analyzing the vector dataset. If you are familiar with the pandas, then it's kind of extension for the geometric operation on geodata. That means it built on top of the pandas, so we can do the spatial operation on geometric objects. And also it further depend on the FINA for the assessing file, and then matplotlib for the visualization of data. I provide you the GeoPandas official documentation, GitHub repo and PYPI release here, so you can simply check through these links. And for the installation, it's quite easy. So if you are installing it through the Conda environment, then you simply have to type conda install -c conda fog. That means we are going to install it through conda fog channel GeoPandas. Or if you are installing it through pip, make sure you have already installed the dependencies, and then you can simply type pip install GeoPandas. But in some cases, I think pip installation is quite difficult, because we this GeoPandas has the depth dependency as the GDAL, PROS4 and GUS. So these packages, I think we have to install manually, and then after that we can install the GeoPandas using pip install GeoPandas. Alright guys, I'm going to create the new notebook on Google Colab. So simply type collab.research.google.com. So you can create the new notebook here by simply clicking on new notebook button over here. So after that, it will launch you to the new notebook. So after that, first thing I want to do is I want to change the name. So I'll type the vector data processing, and then here in the notebook, first thing I want to check whether GeoPandas is available or not. So simply you can type import GeoPandas and then shift enter. So it's running. That means this circle denotes it's running, and then it exit with the error code. So model not found error. That means we have to install the GeoPandas module. So for this you have to type pip install GeoPandas and simply uh, enter and shift and enter to run this cell. Okay, here you can see successfully installed GeoPandas version 0.9.0. So this one is the latest version right now. So we are going to use this version. So now you can type import GeoPandas and then shift enter, and now it run without error. So that means our package is installed successfully. But by convention we have to import this GeoPandas as GPD. PD means pandas and G means GeoPandas. So GPD means GeoPandas. So in this way you can simply import it and then you can use it. So I'll see you in the next. Okay, here I already imported the GeoPandas GPD. So now I want to upload my vector data set over here and then read it through the GeoPandas. So for this, I have to go to this file manager, and then for this, I'll just create the one folder so that I can upload the data inside this folder. So I name it as the data, and then here if I left click it here, so I'll get the upload button. So I can simply click it and then I can select the data and then just click open. So it will upload my data to the data folder. So it's uploading. You can see the process. It pop up with the some like info reminder uploaded data will be deleted when this runtime is recycled. That means when we close this collab, so the uploaded data will be removed. So I also want to upload the my zip file as well. So I have to select these files and then I'll upload it here. Okay, this shows the uploading process. So if I like toggle this, I can get the data set. So for this I'll just copy the path municipality.json path, and then I'll write in GeoJSON. That means input GeoJSON equal to this location of this file. Just simply paste it here, and then in shapefile equal to r, and then my shapefile location. So for shapefile location I can simply copy the path and then paste it here. So now I can run this cell so that my in GeoJSON and in SSP location will be stored here. So after that actually I can read it through the GeoPandas. So I'll name one variable called GPD, means GDF geo data frame, and then uh, I'll read it through the GeoPandas gpd.read file, and then I have to provide the file name. So in GeoJSON. So that means it will go to this location and read it to the GDF. So if I click shift enter, then it will run, and then now my data is loaded under the geo data frame. So if I type gdf.head, I can see the results over here. So okay, so this is my GeoJSON data. It contains these attribute tables: object ID, district, GAPA, NAPA, actually it's the municipality data of the Nepal. So you can see the all the attributes and then the data. So after that, actually this head will provide you the 5 results by default. But if you want the more results, then simply you can type gdf dot head and then you can provide the how many results you want. If I type 10, that means it will provide me the 10 rows. That means 10 results like this. Okay, so in this way, you can simply read the this zip file as well. So for reading zip file, you have to I have to assign the geodata frame again, GDF equal to gpd dot read file, and then I can read the in SHP means input shape file location. So if I again gdf dot head, and then I'll get the same output, because for this particular example I prepare the GeoJSON file and then the shape file, same, both contain the same results. So this way. So if you want to like visualize this data in the some GIS software, then you can simply go to the GIS, and then if I drag and drop this data set, this data set is in here. So maybe if I drag and drop this data set, you can see the data is look like this. And if I go to the attribute table, my data is look like this. If you don't have this ArcGIS software, please, it's not the part of the course. So it's just I want to make sure it's the same data which we loaded over here in the this vector data processing notebook. So also you can visualize this data using mapshaper.org, is the online platform for visualizing the data set. So if you simply drag and drop all this municipality file, then you will visualize the data like this. And then from this inspect feature tool, you can simply uh, get to know about each feature. So you have these things on the attribute table. Okay, so in this way you can read the zip file. So for you can also read the file from your PostGIS database. So for this, actually I can provide you the guide, but because I am using the Google Colab, and then it run on the Google server, so I cannot show you due to firewall issue. So I can, but I can provide you the just syntax. So let me paste some code over here. So here you can see the first line is the SQL alchemy, which is useful for the creating the database engine. And then you have to provide the connection URL, which is Postgres SQL, and then your database username, your database password, and then your host. It might be local host for your local testing, and 5432, and then your database name. And then you have to connect it, and then you can write your SQL like the select asterisk from like your geo database, and then simply you can create the geo data frame, name it as df, like df equal to geodata geopandas dot geodata frame dot from postgis, and then you have to pass the syntax of SQL and then the connection string. If you have the right if you provide the right information here in the connection parameter, and then if you have the rows table in the database, then it will automatically load this data to the geodata frame. So in this way, you can simply load from the Postgres SQL database. But for now, I don't have the end data in the Postgres, so I'll just leave this section as it is, just for the reference. So I hope you enjoy this section, and then I'll see you in the next. Okay, let's learn some of the like metadata of this geodata frame. So I just want to, first of all, I want to know how many records are there in the database. So for that, you can simply type len gdf, which will provide you the length of your geodata frame. So that means here you can see 774. That means this geodata frame has 774 records. So also, if you want to like know the geodata frame coordinate system, and then you can type crs gdf.crs. It will provide you the CRS of your geodata frame. That means it's the coordinate system. So here, this database, this data frame has the coordinate system of 4326, which is the WGS 84 coordinate system. So you can see other informations as well like this. And after that also you can see the geometric type of this data frame. So for this you can type gdf.geom type. It will give you the geometry type of your database. So here you can see all of our record has the polygon geometry type. That means it's the polygon geodata frame. So yeah, this is the some of the like metadata of your data frame. So in the next section I'm going to visualize this data frame in the this Jupyter notebook, this Google Colab. Okay, now it's time to visualize the our vector data set, so our geodata frame. So for visualization, it's quite easy. So you just have to write gdf.plot, because this geopandas use the matplotlib in the dev dependencies, so we can visualize our data using the matplotlib function plot. So if you enter it, your data will be visualized here like this, but it contain all the fill color is blue. So if you want to make the choropleth map using some of the attribute, then you can simply type the column name. So what, I'll show you what I mean. So gdf.plot, and then you have to pass the column name over here. So maybe I can visualize based on the district, this column. So I just copy this, and then if I write here district, and then it will give us the plot using district based on our district like this. So we can see the different districts in different colors. Okay, let me see the data again. So gdf.head. So now I'm going to visualize this data based on province. So I just need to write gdf dot plot, and then maybe I can provide province. And then if I type legend equal to true, it will give us the legend as well. So here like this, so we have this map, and then corresponding legend is available here. By default it will be available at the top right corner, but you can replace this legend position wherever you want. So maybe I can try to put it over here using matplotlib. So let me uh, import the matplotlib package as well. So maybe import plotlib.pyplot is plt. So I have to import it, and then I have to provide the figure and then the axis. So plt dot subplot, my plot will be only one plot, and then for fixed size actually I am going to use the FO size, and then I can write gdf dot plot, and then I have to provide the axis equal to our axis, and then column will be the province is the column name, and then legend equal to true, and I can provide the legend quarks, and legend location will be the center left. If I run this cell, so it will give us the same output, but our legend position will be in the center left. So I want to shift this legend to here, this side. So for this I can reset the legend position. So first of all I have to get the legend. So I'll write ax dot get legend to get the legend, and after that I can set the bounding box to anchor, and then I have to provide the 1.04 and then 0.5. That means 0.5 is the middle position. For y it will be middle, on the middle from top and bottom, and 1.04 means it will be shifted to the this axis. Full map will be the height of 1, so this legend will be shifted here 0.04 distance from this bar. So if I run it again, so my legend will be appear here at the side. So also you can change this figure size as well, whatever you want, but for me I think this is the FO size, so it's look okay. So in this way you can put your legend um, just outside the your map as well. So I hope you enjoyed this section. So I'll see you in the next. Okay, so now let's write this readed geodata frame into our own output. We can save it as the shapefile or GeoJSON or even the geo package. So let's try to write it. So for this, maybe I'll create the ender folder and then title it output, so that my data will be available inside the output folder, so I can write everything inside the output directory. So for this actually you can write gdf.to then to file. If you write this by default, it will use the shapefile driver, and then the output will be the SHP. But if you provide other, if you want to generate like GeoJSON or the geo package format, then you have to provide the extra parameters. So I'll show you what I mean. So I'll just copy this path, and then I'll provide the path over here. So this gdf is our geodata frame, and .to file, and then the this is the folder name, and then I have to provide the file name is uh, out shp. That means my file name will be the out shp, and then if I run it, it will automatically store our geodata frame to the shape file. So if I toggle this button, then I can see out shp. Even I can download this, I can just simply download this data simply by clicking this button, and then download one by one these things, and then I can visualize this data on the map shaper or in the ArcGIS or even in the QGIS. So you can see the same results, same geometry, and then the same attribute table because we did not do anything with our geo database. So this is the by default way to output the shape file. But for the other format, actually you can write GDF to file, and then you have to provide the location, output, and then maybe like out geojson dot geojson, and then you have to provide the additional keyword like driver. This is the driver from GDAL, so you have to provide the driver name, and might be you have to provide the encoding to UTF-8. So if you run it, you will get the this out geojson file over here. So maybe I have to refresh it. So here is our new file. So I can simply download it, and then I can visualize it in the map shaper here. So maybe I can remove this, and then it's downloading. So now it's downloaded. So if I drag and drop here, you can see the same output, which file name is out.geojson. It's the same output from geodata frame, right? So also you can generate the geo package as well. There are lots of different format you can try by yourself, search and try. So content, and then output, and then I have to type gp out gpkg geo package .gpkg, and then maybe I have to provide the layer name for the geo package because package has lots of might have lots of layer. So I have to provide the layer name. I'll provide yam, and then I have to provide the driver gpkg, and then I also need to provide the encoding will be UTF-8. So if I run it, you will get the geo package format here. So let me refresh it. Here gpkg. Okay, so in this way you can like output the geodata frame into various lots of different formats, which you can see here. I outputted it in the shape file geojson and gpkg. Okay, so I hope you enjoyed this section. I'll see you in the next. Alright, if you like this content, please hit the like button, share with your friends, and subscribe my channel. I'll see you next week. Thank you for watching.